creating machine learning model with Python and ChatGPT under 5 minutes. So here we are going to assume that you already know the basics of Python, as well as you have already set up your Jupyter notebook. Okay, let's get started. So first thing that you need to do is you need to download a dataset. In this example, we are going to use classification model, and I'm going to use the dataset that I have created and published 3 years ago. So the link is available in the description. So this is fake and authentic users on Instagram. So basically we want to differentiate between the authentic users or the fake users. There are two CSVs here. We are just going to take the first one and put it on the same folder as your Jupyter notebook file. So we try to open the CSV first. It's better to use text editor rather than Excel for this. So as you can see, we have the data and there are about 60,000 rows. And here we are going to import pandas and seaborn. So pandas is for data frame and seaborn is for plotting. So in case you don't have either of these packages, you can just directly do pip install and then the package that you need in the Jupyter notebook. Okay, so you need to wait until all the packages are finished installing, and in my case I already have them here. Next, we are going to read the file. So pd.read csv, and then you put the file name, the CSV file name, in the parameter, and then we are going to display it. Okay, everything looks good and all the columns are as expected, and we are going to see what these columns mean. So as we can see here, there are about 14 columns. So the meaning of the columns are listed here, like number of posts, number of following, number of followers, and so on. You can read that in the link later. And the important part here is the target variable, which is the user class. So we have the authentic user and the fake users. So usually before we create a machine learning model, we are going to do some analysis. So in this case, we want to do descriptive statistics, which is to analyze the minimum, maximum, the average, the standard deviation, the median, and all that in one matrix. We want to understand the range of the numbers. So here, for example, you can see that the number of posts is on average 176, and the number of biography length is, the median will be 32 characters and the maximum will be 555 characters, and the average will be 57 characters, and so on. You can continue to look at the range of the numbers here for your analysis. And one example that we can see from the descriptive statistics here is the PIC feature, which is the availability of the profile picture. And this is a binary feature, which means 0 for no picture and 1 for has picture. And because the mean here is 0.95, it means that 95% of the people have profile pictures in our data. And another similar one is LIN, which is link, a profile link. So there we got about 28% of the people who have profile link. Okay, can continue to the next. Typically also, after we do the descriptive, we will do correlation analysis to identify the intercorrelation between the features. So it's very easy to do as well with df. So just do df.core, and we can see here the matrix of correlation, Pearson correlation in this case, which range from -1 to +1. And typically we want to find the high numbers, like above 0.2 at least. Okay, here one example here, we see BL, biography length, correlates with LIN, availability of profile link, and the correlation here is about 47%, which means if the user put a longer biography, they also tend to put profile link. So naturally we think, or we hypothesize, that authentic users will tend to put longer biography length compared to the fake users. And we can also hypothesize that profile link is owned by authentic users rather than fake users. Next, we can see other variables too, and we want to spot again the high numbers, which is pretty interesting. Here is the CS. So CS is the cosine similarity between the post captions of the same user. The CS correlates about 22% with the number of following. Means here we can also hypothesize that fake users will most likely have a high number of following compared to authentic users. Okay, and we can also get other insights for this data in the paper that I have published. Okay, next, before jumping into the modeling, we want to get the distribution of the class. Class here, F means fake and R means real or authentic user. So as we can see here, the number of data for fake users and real users are quite balanced because I did that before. And this is very important for classification model. Next, to speed up our process, because we have 60,000 rows, just to test if our code will work properly later on, we are going to cut the data into just 1,000 rows for simplicity. And to do that, we have to first shuffle the data, and we are going to ask ChatGPT how to shuffle the data. And then after that, we can go to the cutting process. Now, this is how to shuffle the data. Again, we need to make sense of it a little bit. So we first need to understand the basics of Python. Okay, so after we shuffle the data, and then we want to cut it into just 1,000 rows of data. Now we're going to ask again to ChatGPT on how to do that. Right, so we have the code here. Which part to take? Probably this guy right here. Right, so we are going to assign it back to df. So we are going to use the same variable, which means now our df have 1,000 rows of data. We are going to check the distribution, whether we get a nice distribution between real and fake users. Now, turns out to be yes, we get a nice distribution because we earlier have shuffled the data. Now, other thing that maybe we want to check is the distribution of the number of following. We can plot the same thing. The limit for Instagram following at that time was 7,600. Probably we can also hypothesize that the high number of following that we have in the data is most probably the fake users. We want to create the machine learning model, and we are going to ask ChatGPT again. So typically we'll begin with a prompt, create a machine learning model, and what are the parameters that we need. So it's mentioned in the given. Now, this is the code. Now, it's also nicer to arrange our code in a modular way so that maybe we can use the same code again in our later projects. So I'm going to ask ChatGPT to create a function for it. Okay, now we have the function. We have a nicely laid out parameters here. We have the df, target variable, and the num faults. So the number of faults is, we are going to do cross-validation testing here, which we can talk about in the later videos as well. So we are going to try random forest cross-validation. We give the df, the target variable, which is class, and then we are going to do 5-fold cross-validation. Okay, and it will return the accuracy number in decimal 0 to 1. And then if we see in the function here, it automatically drops or deletes the target variable for the x. X is the inputs and y is the target variable. So to make a prediction model, we have to have the inputs, which should not include the output. And this is the accuracy scores.mean, which is because the accuracy scores contain the accuracy for each fold. So we are going to just take the average of it. Okay, and then we run it, and we should see the accuracy number displayed here, which is 88%, which indicates that this is a good model. So remember that earlier we cut the data into just 1000 rows of data. So after this, before we test the model in the whole dataset, we are going to ask ChatGPT again how to use or try other models as well. Okay, so this is the code with the same function structure. We are going to use this code and replace our previous code, and from there we can see which one is the best classification model. And it will have some additional codes there. We just need to tidy up according to our preferences. So here there are the algorithms to try already listed, and we replace the target variable with class, and the df we already prepared that before, so we just pass it to the function, and then from there we will print the accuracy. In this case is the results, and the result itself contains the pair of the model name and the accuracy number. Okay, now we have seen the accuracy number there, and still random forest classification is the best model. So after all our code is working well, we are going to enable all our data instead of just 1000 rows as the input for the model. Here, we will disable the shuffling and cutting process and reassign our df based on our original data. After that, you can proceed to rerun the last line of code, and we will see the final accuracy result after about 20 minutes. Imagine we are going to publish this model into an API or a web service, and we are opening it for public so people can actually detect which usernames on Instagram are fake users or authentic users easily. That's all for my video today. Thank you for watching. Subscribe for more.